is, in essence, substituting an entire function into a second function. Two different notations. The first one looks like this. Second one looks like this.
I will see them, but here I'm not responsible for your... Yeah, they're going to get beat.
Good, good. We call these both of the same thing. We call it f of g of x, f of g of x. And what do you notice about the little dot in the second notation?
White.
There's the difference between the white and the black dot.
Because the black dot is multiplication.
Correct. Black dot is multiplication. White dot is composition of functions.
Because we can't get along.
We call it f of g of x, which other notation. So the best way I had to describe it was with these pictures. Is sometimes when we're making stuff, there's two different steps involved. So if we think of yummy McDonald's French fries, they start off potatoes, they go through a machine that's called the slicer, and they come out as raw sliced potatoes. Then we take the raw sliced potatoes, we put them into a second machine called the deep fryer, and we come out with yummy potatoes. There's two different steps there. What's step number one? Slicing them and then frying them. Can we reverse those? Can we do them the backwards? Could we put whole potatoes into the deep fryer, then take those out and put them through the slicer? It wouldn't work well. So sometimes there's more than one operation. That's what a composition of function is. It's doing something to an x value, getting something out, putting what we get out through a second function, and getting out a third value. Andrew.
What about step 3, which is putting about 500% daily value of salt?
I do enjoy the salt, I'm not going to lie. Yeah. So we're going to do it graphically, then we'll do it algebraically. So here's a typical question. Use the graph below to find f of g of 2, g of f of 2, f of g of 1. So typically with these, the hint is you want to start with the inside function. We go inside to outside. So we're going to start with just g of 2. I'm going to ignore that f for a second. I'm starting with the inside g of 2. What that is asking you without using the words, it's saying go to the g function, go where x equals 2, find the corresponding y value. Going to repeat that? It's saying without using the words, go to the g function, go where x equals 2, find out what the y value is equal to. So I'm going to use the ruler just like I did yesterday because it helps my eye a little bit go to the right function. So I'm going to go where x equals 2. Because it's g of x, I'm going up to the g function. Then I'm going across. What's the y value? Do we all agree f of g, or g of 2 is 1? Then what this is saying is now take that answer and put it into the f function. So we did the outside, or the inside, now we're working to the outside. F of 1 is saying go where x equals 1, go up to the f function, find the y value. Final answer. That's what the question is asking. It's two different functions. It first used the g function, then it used the f function. What's the difference between A and B? It's the order. So we're now going to start with f of 2 first. It's the inside function. That means go where x equals 2, go to the f function, and find the y value. Agree that it's 0? Now we take that answer and we go to the outside, so now g of 0. What's that asking? Go where x equals 0, look at the g function and find the y value. Well, there's no function there.
It's undefined.
Undefined. No. F of g of 1 is just a different x value, so a different kind of input. Where do we start with this?
G.
We go to g of 1 first. So go where x equals 1. Look at the g function. Get the y value. I'm hearing really quiet zeros. So this now becomes f of 0. F of 0 means go where x equals 0. Look at the f function.
It's kind of off the map.
Yeah, so we're just going to continue it. If it's off the graph, then just keep drawing the line. We know it's linear. Four, I think we're good saying. That's it. That's a composition of functions. It's a function within a function. It's just 2 steps. No, keep the rattling, kitties. It's not going to happen. Now we're going to do it algebraically. So the graph was the easy part. Now we're going to deal with actual functions. So f of x is negative x negative 5. G of x is x squared plus 2. What kind of function are each of these? Turn and talk. Tell your partner what kind of function is f of x, what kind of function is g of x. I heard people saying it's super fast. F of x is linear. How do you know? How do you know the other one's quadratic?
Because grade 2.
Okay, don't write this down. Just follow with me from grade 9, grade 10. What does this mean? So it's a notation without words. It's telling you to do something. What is it telling you to do? Yeah, take out x and put in 3. And if I were to put a negative 2 in there, for example, what does that mean?
Replace x with negative 2.
Replace x with negative 2. And what if I went like all crazy town and put an a in there?
Replace x with a.
Replace x with a. And what if I like put a y in there?
Replace x with y.
So what does this mean?
Replace f with g.
Replace x with g of x. I'm going to put that in words for the wordy people. Replace x with g of x. So it's a function with inside a function. What that means is the x in f of x is going to come out, and the entire g of x function is going to go in. The x is going to come out, the entire g of x function is going to go in. So I'm going to leave that negative, and I'm going to leave that minus 5 at the back. All I'm going to do is take out x, and what am I putting in its place? X squared plus 2. That's called a composition of functions. It's putting one function into another function. And then we would just simplify. So what do I do with this negative in the front? Just distribute it. So a negative times x squared is negative x squared. And a negative times a positive 2 is negative 2. And then I still have that minus 5 hanging around at the back. And then I would just simplify it. Negative x squared minus 7. That's a composition of functions. Okay, what does g of f of x mean?
Replace x with fx.
Replace x with the f function. So I'm going to go to the g of x now. I'm going to keep that squared. I'm going to keep that plus 2. I'm going to take x out, and what am I going to put in its place? Negative x minus 5. Sometimes in the textbook and on the exam and on the tests and quizzes, they will say, state an explicit function for example, this. Explicit is the same as simplified. So if the question says simplified, you're going to simplify. If it says explicit function, you're going to simplify. Let's pretend it's explicit just so we can practice. How do I simplify this? So what do I do with this binomial squared? Well, negative x squared is x squared, and negative 5 squared is 25. Can I just distribute that exponent? No, that's kitten killing up there. It doesn't work that way. If it worked that way, grade 9 would have been easier for you. How do we do a binomial squared? Well, we FOIL it out. So some people, it's going to help if you actually write it twice, because then your brain is going to see that factoring. If your brain already saw that, don't feel you have to write it out twice. But you can't just distribute a negative. It doesn't work that way. So this becomes negative x times negative x. The outside is negative x times negative 5. The inside is negative 5 times negative x. And the last term is negative 5 times negative 5. And then I still have that plus 2 hanging around. So how is it that we had all these negatives and we have no negatives over here in the simplification? Yeah, because it's all negatives times negatives. Now just collecting like terms, x squared plus 10x, I heard, plus 27. Make a note, that's called explicit, which means the same as simplified. Ooh, ding dong.
I don't know. I've never heard that before.
So this is what a disposition a function looks like when there's just x in the inside brackets. What happens when they're a number? Well, a number we do in 2 steps, just like we did with the graph. So this one we're going to start with f of negative 2. What does that mean, f of negative 2? Yeah, go to the f function, take x out, put in negative 2. So it's going to be negative 2x minus 5. Oh, no x, sorry. Negative 2 minus 5. What happens with our negative 2? Cancels or becomes positive, so I have 2 minus 5, negative 3. That's step 1. Step 2 is saying take the g function and evaluate that negative 3. So going to the g function, taking x out, putting negative 3 in. Simplifying, I heard 11. Confirm 11. Do you see the difference when it's got an x on the inside and when it's got a number on the inside?
Yes.
What happens when it's a function within itself? F of x. What is that? Well, that's like sticking a paper through the photocopier and then realizing it's not dark enough, so what do? You put it through the photocopier again. So there's different functions in life that we run over and over for a certain reason. So this is just sticking f of x into itself. So that means take out the x and put in f of x. So I'm going to keep that negative. I'm going to keep that negative 5 that's at the back. I'm going to take x out, and what am I putting in?
X minus 5.
There's a function within to itself. Now we just simplify the way we normally would.
X.
What happened to the numbers?
Well, 5 times negative 5 times negative equals plus 5, and plus 5 minus 5 is 0. Negative x times negative is x, so.
So these are the 3 types of examples you're going to run into. Is just a function where there's x into another function, a number with a composition of functions, and then you can have a function into itself. Which, just note, you can do these things more than twice. You can have a composition of functions where it's f of x, or f of g of f of x, or f of g of f of g of x, etc., etc.
But we wouldn't.
Oh, we might.
Why exactly do we need to know this?
Oh, because you'll combine functions all the time in sciences. All the times. Right? Just like when you make fries, right? 2 steps to it. Anything that's got double processes, you'll always do composition of functions.
Do we have to graph this too?
Oh, maybe.
Oh god.
Example number 3. Let's do the same thing, but with without polynomials. Now we're going to do with rationals. Aren't you excited?
No.
Given f of x is 1 over x plus 2, and g of x is x minus 4, find f of g of x and state... Oh, that's my battery dying. That's what that red one's for. Ah, the battery's going to die in there outside. Oh, what is this?
F. Replace x with g of x.
It's just the other notation. How do you know it's not a multiplication?
Because it's not black.
Right, because it's got a white dot. So this is saying take g of x and put it into f of x. So it still goes from inside to outside. We're going to take g of x and shove it into f of x. I'm keeping the 1 on top. I'm keeping the plus 2 on the bottom. All I'm going to do is take out that x, and what am I going to put in its place? X over x minus 4. Okay, so the x came out. G of x went in its place. We're going to simplify just for the fun of it. So think of this like identities, just without the sines and coses and tans and cotans and cosecants. Where would we start simplifying if this was an identity? Common denominator on the bottom. So right now I've got the imaginary 1. What's the common denominator between x minus 4 and 1? Okay, so 1 on the top is going to stay. Haven't touched them yet. The first fraction is going to go over x plus or minus 4, and the second one is going to go over x minus 4. What goes on the top of the first fraction? Just x, because it didn't change. I multiplied by 1. What's going to go on the top of the second? And I just want to be sure that we're bracketing that x minus 4 or we're multiplying it through right away. But either way, you can't just put 2x minus 4 without the brackets. Okay, once we had common denominator, what did we do with identities?
Smush the top.
Smush the top. So that 1 on the very top's still going to stay. I'm just going to have x minus 4 on the bottom. the top, what's going to happen? Well, I'm going to have this x. And then I want to distribute through here, so I've got 2 times x, which is?
2x.
And then 2 times negative 4. And then I want to combine these x's here, so I still got that 1 on the top that I haven't touched. On the bottom in the numerator I have 3x minus 8 over x minus 4. Now what? That bottom is as simplified as we can get. It's a small and a simplified. What do we do with it? We flip it. Why do we flip it?
Because to divide, you have to reciprocal.
Reciprocal, and because it's times 1, we can straight up flip it, so this is going to become x minus 4 over 3x minus 8.
Can you, it's like, you can't-
Oh, there we go. This is about as hard as the simplifying we would expect you to be able to do. What's the domain? Well, how did we do domain of any kind of rational function? Going back to unit 4 with asymptotes and holes. So it's something to do with the non-permissible values, yes.
you know that there's an asymptote, a horizontal asymptote.
Except horizontal doesn't affect domain, it only affects range, so we only care about
Range.
vertical asymptotes. How do I find the vertical asymptote in this?
Equate the bottom to 0.
Yeah, equate the bottom to 0. So we start with saying XER, just like we do with all functions, but then we say x cannot be
What, 3 over 8?
8/3. Questions so far?
How in the range?
To find the domain of a composition of functions, you must look at the NPVs of the composition as well as the NPVs of the inside function. So this actually isn't our domain finished yet. This is just the NPVs of the composition. What also will affect it is the NPVs of the inside function, which in this case is g of x. So it's not just that x can't be 8/3, x can also not be 4. Just making a note, this is the NPV of f of g of x. And this guy is the NPVs of g of x, which is the inside function. That's the way domain's always going to work with a composition of functions. You take the composition and the inside function.
Do we also have to know how to do the range or not?
They could ask, it would work the same way, so you would just take the horizontal asymptotes of the two, the inside and the composition. Or oblique asymptote if there was one. How are we doing so far? Are they making eye contact? Making you feel that? I enjoy because you relate to you, so that makes me happy. Let's do some radicals. We've done polynomials, we've done rational, let's do some radicals, and then some absolute value is going to come out. Let's do a turn and talk. So try this one together while I go talk to the wayward people in the hallway.